Ladies and gentlemen, how's it going? This is Mike. So today we're going to do a pretty big dive into weather. We're going to start with the basics, move on to some intermediate stuff, finish with the advanced, but hopefully this video can hit a lot of different people and their needs. If you're beginning, just do the first section. I'll tell you when you could tune out. This box is going to disappear so you can have the full screen to see what we're going to watch, and I'll talk to you later. Okay, so the beginning, basically weather. Let's do a very quick definition of what weather is. It's just describing the state of the atmosphere. So what we observe, whether it's clouds, rain, wind, whatever the case is, that's what weather is. And let's look at two extremes right now. Both of them are actually in Iceland. This is Icelandic wind, right? Welcome to Iceland, 26 meters per second at Grímsvatn, the volcano, the hut, you can stay out there. Beautiful day, snow kiting on the ice cap, exceptional high pressure. So a very important thing to understand first is atmospheric pressure, or the weight of the air above us. And we can see here in this area we have basically air molecules which have weight, and then there'll be a measuring area down here, a weather station, measuring that, and that will give us a number in millibars or hectopascals. And that measurement tells us what conditions we can expect around us at that given time. So basically, in short, we use a measurement of the weight of the air above us to tell us how the weather is and how it will be forecasted in the future. So pressure systems. Let's first establish something we need to understand. Nature seeks a balance of 1,013 hectopascals, meaning the weight of the air is 1,013, and that is what nature seeks, a balance, a symbiosis. But there's never that symbiosis. There are always low pressure and high pressure systems, and they're trying to balance each other often, and that balance is what causes weather to occur. And we can see that description here. So for example, to give us some ideas, we have what's called a high pressure system here, a high pressure area, basically known as anticyclonic. And the winds tend to be light, and they blow in a clockwise direction. So as we can see here, a clockwise direction. And high pressure generally gives us good weather. If we have a depression, a low pressure, which we see here, air is rising. This air is rising and it's going in an anti-clockwise direction. And these are both in the northern hemisphere. In the southern hemisphere, we have different directions, but the northern hemisphere, we have the high pressure going clockwise and the low pressure going anti-clockwise. Now, for this low pressure, as the air rises, the air cools, condenses, and we have clouds. And then you could see this low pressure, we have this air going to the high pressure, and now it's coming down. Right? So heating up, we don't have clouds here, coming down, heating up, and now it's going to the low pressure. And this is this cycle that's continuing over and over again. And this system, this high pressure, wants to equalize to the low pressure. The air travels from high to low, which is why we have wind. And this is wind here. Right? So this is a really nice cyclical process that we're talking about. Now, to give you an idea again, just to describe what we described previously, we have here the cold, cool air coming down, warming up, and then it's going to low pressure systems, and then it's going up, condensing, forming clouds, and we have precipitation. In between, we have wind. Now let's talk about how we measure weather. So here we have various numbers scattered out throughout the United States, and each weighing station or each weather station is taking the ambient pressure, meaning the pressure of the air at that area, and they're giving you a number. So for example, if we go into my hometown, let's say Philadelphia, we have 1009, but if we go into Texas, we have 1040, meaning the weight of the air in Texas of a column of air is 1040 at that location, 1040 hectopascals or millibars. And same for Philadelphia, but a different number, 1009 hectopascals or millibars. And this is typically what you don't see. What we do see are isobars. And let's talk about isobars now. So basically what isobars are lines that connect the same pressure. So now the map's starting to take shape. So for example, we see high pressure here, and we see basically it's connecting 1044, 1044, 1044, 1044, 1044. So it's connecting all the 1044s, and you have lines of the same pressure that are connected. Once again, those lines are called isobars, and they're very important to understand. So just to review, this is how the map would come to a weather forecasting service, and they would connect the lines into isobars, and then this is what they would be making. But what would you see? What you would see, it's something similar to this, and we have the same for Iceland, but this is the UK Met Office. Fantastic resource for weather. And here you have isobars. So these are lines of the same pressure. You don't see the thousands and thousands of dots that they're connecting. You just see these isobars. And in this map, what is convenient as well is once you connect the isobars, they identify areas of low pressure, as we talked about, poor weather, and then areas of high pressure, which is good weather. We have a nice high pressure here of 1026. We have a low pressure of 980. And just to review, what nature wants to find is 1013 hectopascals, with the high going to the low, right? It wants to equalize. So we have a huge low pressure here. Now, just to tell you a little bit about reading this to a greater extent, so many people who have gone hiking will have seen this map, and this is a topographic map, which gives you contour lines, really excellent way to see the hike ahead of you, and if you want to take a specific area, how steep the area will be, because the contour lines basically connect areas of the same elevation. And that's the same for isobars. Isobars connect areas of the same pressure. So in this case, we have, let's say here in this town of some city, which I don't know, the lines are very spread out. So that means it's relatively flat, not much is going on. But as we get into the mountains, we have the contour lines are very close together. It gets very steep and it will be very hard to climb this. So now let's go back to the pressure map. As we can see here, once we return to this map where we have the pressure, the isobars, we have here in this high pressure, very spread out isobars. So very calm conditions, very good conditions. As we go to the low pressure here, we see the isobars are getting much closer, much steeper, and as you saw in the last contour map, that means we have some hard weather coming ahead, some potentially dangerous weather we have to consider. So the closer the isobars are, the worse the weather is. The further they are apart, the better the weather is. So what's the purpose of knowing weather? What's the goal as a guide? And we have three main goals. The first goal is planning for yourself, the second goal is planning for guests, and the third goal is planning for your operation. And right here we have what's called a wind chill table. And this is a great table available on vedur.is, vedur.is. And this shows you at a given temperature, which we have in Celsius here, and a given wind speed, what the wind chill would feel, what it would feel like outside. So for example, if you're taking a tour and it's maybe -4, -6 in the winter, it's not that bad in temperature, but let's say we have a forecasted wind of 12 meters per second. All of a sudden that -6 turns into -16, which for a client, that's fairly extreme for a client. That's definitely a situation which I need to be thinking about protecting that client from the weather, or how to maybe change the tour time so we're not hitting those conditions, or giving the client enough gear. So let's review once again. We have a plan for yourself, meaning how are you layering, what are you wearing? A plan for your guests, what clothes do they have on? Do they have jeans? Do they need gloves? Do they need hand warmers? Maybe you have to bring a shelter because we have pretty heavy wind that day, or we have 12 meter per second wind, and we just want to have the option to get them out of the cold just in case. And then we have a planning for the operation. So on a large scale picture, are we running the tours today? And typically many operations will cut it off at 15 meters per second. And then we have different figures when we include rain. But generally speaking, you're also looking at the operational standpoint of, are you running tours? Is it safe to run tours? So now let's talk about winter and summer conditions. And this is based off the last point of what are we planning for, both ourselves, our guests, and the operation. In regard to winter and summer conditions, the glacier looks very different. So in this case here we have Breiðamerkurjökull, and this is a winter tour. Now the most important thing to look at as a guide is this blue ice we see here. This blue ice, once a client slides and falls down, they're gone. This is very, very slick ice. But also on the contrary point, if we come to the same location in the summer, we have summer crust. So if they fell and they tried to slide with a running start, they would not go anywhere. However, they would definitely cut their hands if they fell down because this summer crust is very sharp. So we have to plan for both differently. In the first picture, I wouldn't bring any groups up here without a fixed line in this condition. However, in this picture, you can have groups of up to 13 follow you, and I will feel very confident as long as we're managing these areas here where they could potentially get injured if they fell in. But just to know there are differences in regard to weather from winter and summer. Now let's move on to the point of making a plan for getting caught in bad weather. And this is also, again, a plan for yourself. Talking about the last point, which is plan for yourself, plan for your guests, and plan for the operation. Planning for yourself, you need to be prepared in case something happens and let's say a whiteout descends or really heavy rain, you have to get back and you lose your visibility. So what do? We have two basic options. The first is to make sure you have a GPS track. I have the GPS track of my tour last year, the GPS track of my tour this year. They're loaded onto my phone and onto my watch, so I have two options. The next point we have here beyond GPS track is we can handrail. So we see this very prominent mountain here, and if I know this mountain is north of me and I'm somewhere up on the glacier going to an ice cave, I just go to the mountain instead of trying to find the path back. I can go to the mountain and follow the mountain down to a known location and then follow it back to the car. So that's called a handrail, meaning using something that's a known location, something you can identify and see easily to navigate back to a location which you know. Now we're going to jump into two weather services, which are what we're going to use for forecasting here in Iceland, or what I recommend using for forecasting. The first is called vedur.is, which is vedur.is, and this is the Icelandic Met Office, a fantastic resource. And the second is called Belgingur, and this is belgingur.is, and this is also based in Iceland. Now there is a difference between the two, and basically the difference is the model they use for forecasting or how they calculate their forecasts. Vedur.is, or the Icelandic Met Office, is in collaboration with the European Center for Medium Range Weather Forecasting, or ECM, or ECMWF, which operates a supercomputer in Europe to run the forecast models, which Vedur.is uses to make very local models. And Belgingur, and the forecast for Belgingur uses what's called GSM, or the Global Spectral Model, run on the Global Forecasting System, operated by the National Oceanic and Atmospheric Administration in the United States. So that's where they run their model, and then Belgingur makes a hyperlocal forecast so you can see small differences that would be caused by topography here. Now, in regard to comparing both GSM, the model that Belgingur uses, and ECMWF, the model that Vedur.is uses, or the Icelandic Met Office on this website, ECMWF is considered to be definitely a more accurate forecast because it takes into account altitude and topography, so how the land is laid out. So generally speaking, the ECMWF is a more accurate forecast, but we'll learn how to use both later in the video. Okay, so let's transition now to what we're actually going to do with guides, how we're going to get the weather, what the point of this is. So we're going to start with what's called the macro or large scale forecast. So I'm going to go to weather, and then on weather, I'm going to go to the Atlantic Ocean forecast, because I want to see the large scale photo of what's happening around us, because that weather will affect us days from now. So for example, if I have a tour on Monday that I really want to do, then I want to make sure I check this forecast out to see how Monday will be forecasted. But let's talk about this a little bit more. If we look here at Greenland, now Greenland has what I'll call Greenland highs. So we have high pressure, and the high pressure and low pressure are battling. That's why we have pretty high pressures here, usually pushing low pressures in this area between Iceland and Greenland, and not allowing them to go to Greenland, but keeping them in this little area. Also will force them south, and then they travel south of Iceland and then go northeast in this area here. So this is a very common path for low pressures due to the Greenlandic highs, which are basically high pressures pushing away the low pressure systems. Now if we look at this, we're going to scroll through, and we can scroll through every 3-hour chunk. And we could see some movement here of the weather systems. We see them, this low pressure here, let's see what happens with this low pressure. So it goes north, it's kind of getting pushed from Greenland. The Greenland high is not letting it go, getting pushed hard against the coast. So it's staying around for a few days. Then we have this nice high pressure here. So then the weather becomes fairly stable. We have some of the end of a low pressure system here that was touching Iceland previously. So we have some of that happening maybe on the transition from Saturday to Sunday, as we can see here in the south coast. Moving forward, and we have a massive low pressure, well, not a massive, but we have a low pressure coming in here, hitting Greenland, dissipating completely. And that low pressure comes back again on Tuesday here. We have another low pressure moving this direction, So we have a kind of an interesting low pressure system here. Some high pressures here further south of Iceland. But let's look back at Monday. So this is the tour we want to do on Monday. So if we look through Monday, it's 6 a.m., 12, 18. Looks pretty good. So I would feel confident with the tour. But we have to also check the weather in regard to temperature and precipitation. So I'm going to hit 2 on my keyboard. I'm going to temperature now. I'm going to go back. I just want to see how today is. I'm going to scroll through temperature. And here's the temperature on the bottom, the Celsius. And going back to wind, this is the wind speed on the bottom here. 0, 2 meters per second, 4 meters per second, 6 meters per second, going all the way to 40 meters per second. Let's go back to temperature. As I scroll through the days for temperature here, I can see, so the temperature is increasing. Thursday getting warmer. Pretty warm on Friday. Still pretty warm. Getting a little colder. So Sunday's much colder than it was earlier in the week. So Monday's pretty cold. So the day of my tour is going to be pretty cold, maybe about -3, -5, according to this large scale forecast. So that's something I should consider, maybe extra layers for my clients. Now let's go back. We're going to look at precipitation now. You can hit 3 on your keyboard. You're at the precipitation. You can also hit the left or right arrow as well to move. We're going to start with Thursday. Look at the precip. This low pressure is bringing precip here. Let's see what happens. Yeah, this low pressure right here is bringing precipitation. Looks like it's hitting Iceland. Now it looks like on Friday we have some rain in this area. Okay, that's something I should be thinking about. Again, transitioning into Saturday, definitely have some rain. Okay, dissipating, rain again. Wow, rain again on Sunday. Looks like Monday, that day for the tour, is looking pretty good. I'm pretty happy with it. But we have some weird weather coming in for the previous days. So that's something I should be keeping an eye on, how this develops in the ocean. So that's the macro perspective, the large scale perspective that we're looking at. And we also have this counterclockwise motion, right? This counterclockwise motion to the low pressure. So the wind then is hitting Iceland from the south. We have southerly winds. Even though the low pressure is west of us, we have winds from the south due to the spin of this low pressure system. Okay, so now we're going to move to the micro forecast. We're going to check our local area since we've already checked the large scale forecast. I'm going to click on weather again. Now this forecast here is nice for the average person, but for guides, we definitely want to progress away from using this type of forecast and going into the wind, temperature, and precipitation forecast, which paints this nice, beautiful picture here. We've already looked at the large-scale forecast. I'm interested in now specifically maybe Ödevejökull or Breiðamerkurjökull. So southeast is what I'll click. And now let's talk about some things we see here first. So the outside of the box here, we have some important information. On the bottom of the box, we have the wind speed measured in meters per second. On the top of the box, it says wind, and it's calculated at 10 meters height, at 10 meters. So that's significant. We'll talk about that later. But wind at 10 meters. And this is the DMI IGB forecast, and this is plus 4 hours from the time it was given to us. And this will go out to 66 hours, right, if we progress through. And it gets to 66, and you'll notice something happen here. Forecast changes to ECMWF. So basically, to give you an idea what's happening, the DMI, so the DMI and the Harmony are two forecasts that are run in Iceland to give us hyperlocal weather patterns, and includes topography, and it has a much higher resolution, which means the box which is calculated is much smaller. So the Harmony and DMI, which you would see here, DMI and Harmony you would see here sometimes as well, gives us a box that's between 2.5 kilometers and 3 kilometer resolution, and it goes to 66 hours. So that's what you really want, up to 66-hour forecast, to get an idea of how the weather is going to be and to have a fairly predictable forecast for Iceland. Now once you go out past 66 hours, and you'll see up here on the upper right, I'm moving past 66 hours in a moment. I get to 66, I go to the next forecast, and we have a jump here. We have this pretty heavy wind here, 18 meters a second, and all of a sudden, 3 hours later, we have almost no wind, very calm conditions. So this jump usually means that the forecast model has changed, and the ECMWF, remember that's the European forecasting computers, the supercomputers, that are giving us a worldwide forecast. So it's a very rough estimate they're giving us for Iceland. They're not accounting for the topography. They're not giving us a very detailed view, and the resolution for this is 9 by 9 kilometers. So it's a much, much bigger area that they're forecasting for, 9 by 9 kilometer chunk. So they're not accounting for all the small things that would happen in the other forecast for DMI and Harmony, which are giving us between a 2.5 and 3 kilometer area, 3 kilometers squared, 2.5 kilometers squared, they're forecasting for. So you always want to go for the higher resolution, but when the forecast jumps, you're going past 66 hours like I am now, you're moving into the ECMWF, worldwide forecasts provided by the European supercomputers that are not extremely accurate. Okay, so now I went into that. Let's just look at the actual forecast and see how it's developing. I'm just going to scroll through with my right arrow here. So we have some wind on Ötevökut here. I have some wind up here in the northern part of Vatnajökull. Looks like it's increasing. Yeah, we definitely have some a low pressure. We have some very heavy wind in the northern part of Vatnajökull. Looks like Ötevökut is getting hit. The western side of Ötevökut, Skaftafell, we got hit by Fjallajökull. Also, Skeiðarárjökull is getting hit pretty hard. Let's see how it progresses. But this is before the tour, 7 a.m. So I want to see what's going to happen during the tour. It looks like about 10, so it's calming down at 10. Okay, I feel good about this. This is looking to be a pretty good forecast. So basically, we're going to look at maybe from 9. So maybe we would start a little bit later. Maybe I'll start the tour about 10. And I feel pretty good with this. And this is just the wind, as I said. We're looking potentially anywhere from 2 to 6 meters per second, which is manageable. Let's look at the temperature now. So you can hit 2 on your keyboard. Bring yourself to the temperature. We're going to start at the time of interest, which is 8 o'clock in the morning. Very warm temperature, so 11 degrees Celsius. Temperature is dropping, it looks like, throughout the day. But it's still staying very warm. All right, so we're talking about temperatures anywhere from 2 to 5 to 6 degrees Celsius. So very warm temperatures, especially in this area where we'll be in Fjallajökull. We're looking at 4 degrees Celsius, 5 degrees Celsius. So that's a fairly warm day, so I'm not concerned about the temperature. Let's go to precipitation by hitting 3 on your keyboard. So let's look at precip for the day. Start at 8. Okay, we have some rain, some heavier rain, lighter rain. Let's look at the actual numbers. So maybe at about, we'll start, looks like at about 11. We'll start at 0.1 millimeters per hour. And this is measured up here, as you can see. This is millimeters hourly. So that's 0.1 millimeters per hour. It's a very, very light rain. We're going to get into a little bit heavier rain. Looks like we're getting into 0.5 millimeters per hour. Back to 0.1, so some drizzling. Okay, so it's progressing. Which is, it's not too bad, but it's definitely not exciting for the client. We're going to have some rain, which is not ideal. So now, if you take all this as a whole, and you're giving this report to your boss or to your other guides, or just making your clients aware of the situation, what are they preparing for? So I would tell my clients, all right guys, so we have pretty good winds today. We're going to start a little later today than we anticipated, because when we look at the wind forecast, we're going to start at about 10 instead of starting at 9. And we should have better winds. We're looking at winds maybe 4 to 6 meters per second. So what I recommend for you is just have a light insulating layer, and just in case a rain breaking layer, because we are going to have some precipitation throughout the day. It's going to start as light precipitation. As we can see here, it's going to get a little bit heavier, but nothing that's going to be too concerning for us. And then it's going to keep with light precipitation throughout the tour. So we're going to have our rain jackets on. And also, of course, I would just bring gloves just in case, because when you get wet in 5-degree weather, it's going to be a little cold. So that's the summary I would give the clients, and that's the summary you can also give to your other guides, and that's what we did with weather. Now, a cool thing to look for as well, and this is if you happen to be going on a peak or anything that you want a good view, go to cloud cover forecasts. I just want to see the cloud cover for tomorrow. So let's just see what we have here. Let's go to 8 o'clock in the morning, and not exciting at all. Yeah, so this is not ideal. And we have, I guess, whiteout conditions, pretty low clouds. Now, if we go to lower clouds, we can see, so we're going to have clouds most of the day. Okay, mid-level clouds, stratus clouds, and then cirrus clouds, high clouds. Okay, so we have a lot of lower clouds, so it's definitely not ideal conditions for seeing anything beautiful. The view won't be that great. That's something for you to note. Now, I hope you enjoyed the presentation in general. So that was a very short summary of weather. Now, if you want to stick around, we're going to go a little bit more into detail of kind of the weather geek stuff. So let's start with that. All right, guys, so welcome to part 2 of this weather discussion. So for this, we're going to go into a little bit detail about a resource we have called Brunner, which is basically run by Veður.is, the Icelandic Met Office, and gives us kind of pretty detailed forecasts that allow us to dig into the weather. Now, to find it, we go to Brunner, brunnur.vedur.is, and we go here. I'm going to turn this on to Icelandic so you'll see what it looks like. We're going to go to Spárkort, click that. That brings us to a lot of options, a lot of maps we have here. And we're going to go down and look at a few maps that are fairly important right now. So we're going to scroll down to what we see as ECM0215. ECM0215, there it is. And I'm going to go to this here. Click this. Now, for those of you who want a pretty detailed analysis of weather, the best thing to do is compare the different models. So here we have the European model versus the American model. The European on the left, the American on the right. And if the forecasts agree, generally you're going to have that forecast. You're going to have that weather. So if we scroll through the days, we can see where they agree, where they differ. So they agree with this low pressure system on the southeast coast of Greenland. We have some poor weather coming into Iceland. And this top is precipitation, by the way, as well. Okay, so we progress through the week. And where do they differ? Let's see. So it looks like they're differing right here. So on the first, looks like we have this low pressure here, some rain. It looks like it's differing here. We don't see it in this area. So already at this point, the forecasts differ. And if I was thinking about, okay, what's going to happen on the 1st of June, I have something, some type of tornado, then I would just know that in the Atlantic Ocean, we have a differing forecast. Something is happening. Also, if we look at Iceland as well, it looks like we have pretty stable weather, but it's worth noting that the forecast is differing on that day for west of us now. Now, if we progress to a concern of Iceland, let's see, looks like we have something there on the European forecast, some precipitation here, not showing up at all on the American forecast. That's something to consider as well. So whether there will be rain or won't be rain, that's something we're not really sure of. But this forecast is 132 hours out, so that's still pretty far. But yeah, if we progress through, so this is a great idea just to compare both forecasts, compare the American and the European models just to see if they agree. If they do agree, generally, that's what's going to happen. If they don't agree, then I'll wait till the forecast gets a little closer to us and then make a call there. So the next cool thing I'm going to look at is going to be under Harmony IGB. And I'm going to look at this right here. And this is the 100 meters, so wind predicted at 100 meters of elevation. If you note that the standard forecast is 10 meters, so this removes a lot of surface friction. We can progress through. And this is just a nice resource to see what we're looking at when we remove that surface friction and vegetation in homes and anything that would impact at 10 meters of elevation in the forecasting. Now there's another cool option. We're going to go back here. Again, under Harmony IGB. There it is. Let's go here. So this is wind forecasted for 1,524 meters. So if you're going up on the ice cap, for example, I would definitely check this out. Sometimes you do notice a difference between the actual forecast on Veður.is and then the 850 hectopascal forecast. So yeah, this is a really great forecast to see the wind forecasted at that point. So as we progress through, we can see. And now the final thing we're going to look at. We're going to look at the aviation forecasts. So these are the aviation forecasts. This is FL000, 10 meter forecast. This is 2,500 feet. This is the forecast that's given at 762 meters. And then we have 5,000 feet. This forecast is 1,524 meters. These are three useful forecasts to look at and progress through. We could see what we see is wind and heat. And we progress through and see the large scale photo of what's happening. Again, similar to the Atlantic Ocean forecast, but giving us kind of Iceland in general and giving us at different elevations, being, if you're doing the ice cap, I would be looking at this 050 forecast. So in conclusion, I hope you enjoyed this weather synopsis analysis. And until next time, this is Mike. Take care.